I'm here with Dr. Romano, and we're going to do a problem with salts.
Come on in, let me show you a really great problem. I want to go over a problem with you involving hydrocyanic acid having a Ka of 4 to the minus 10th. I want to find the pH of a 0.2 molar solution of sodium cyanide, which is the salt. Now, before we start, the numbers will be nicer in the destroyer and on the DAT or the OAT exam. So don't be too worried about the numbers not being so wonderful. What I care about you understanding is understanding the chemistry. The nice numbers, the easy numbers to work with will be when you get to the exam in the destroyer part. The first thing you're going to do is to remove the spectator ion from the salt and examine the hydrolysis reaction, meaning what happens when cyanide reacts with water. When cyanide reacts with water, it picks up an H to give HCN, and you're left with OH minus. Because OH minus is given off, you're going to write what's called the KB expression, which is the products divided by the reactants. The chemistry's over. That's it. All you got to do now is we're going to just be doing some plug and chug. We're given the Ka, but we don't want the Ka, we want the Kb. So Ka times Kb, as you know, is equal to the Kw, which is 1 to the minus 14th. Plugging in the value of Ka, I solve for the Kb. Once I know the Kb, I go back in and plug my numbers in. 2.5 to the minus 5. This and this are equimolar, so I'll call them both x, so that's x squared. At equilibrium, we have 0.2 minus x, because we've lost some of this, but we're going to make an assumption that this is very, very small, so I can neglect it. So when I neglect it, it becomes 2.5 to the minus 5 is x squared over 0.2. I cross multiply and square root it. This might be good practice for you to try. That's going to give me x equaling 2.24 to the minus 3. And that x would equal this and this. Since we now know the OH concentration, we can get the POH, which is minus the log of 2.24 to the minus 3, which gives me 2.65. Once we know the POH is 2.65, we subtract it from 14 to get the final pH, 11.35. So this solution of NaCN would be basic. Now, if you wanted to do this problem without any numbers, all you would do is a little trick. You would write NaCN, and you would simply put it in water, like I show you in the destroyer, and you crisscross, and you meet the parents. The parents are NaOH and HCN. NaOH is a strong base. HCN is a relatively weak acid. The base predominates, so therefore we would have predicted that this salt solution would be basic. So if you ever had a guess, the guess would be over 7. All right, I hope this wraps up how to do a problem like this. We have 2 or 3 more in the DAT destroyer that I think you'll really enjoy, and they'll be done in an analogous way. All right, good day to you, Miss Alexandra.